recording. Turn red. There we go. We're recording. Okay. So I'm going to throw the average up here. Here we go. Equals average. Or excuse me, not average. Sum product. Equals sum product. Did I spell that right? I did. That and that. So I get an average of about 3.78. Hope that's the same one you got. Should be the same calculation. Same math you would have gotten back in Math 98 or the beginning of Math 105 by doing that times that plus that times that plus that times that. It's just shortcuts for you. It's one of my favorite products. It's one of my favorite formulas in spreadsheets. So quick. All right. Now, I also add for the mode and the median. Now the mode, hopefully, actually, tell me your thoughts on the mode. Yeah. What do you remember about this? Josie, say it, please. It's the most frequently occurring point. Now, last week or so, we used a command to find it. Yeah. But the beauty of having the data like this is you don't have to use the command. Here are all the data points. These are all the different things that could possibly happen. Which one happens the most frequently? 3. How can you tell? It happens 28% of the time. The biggest number that happened the most frequently. Look at what Josie said. It's the data point that happens the most frequently. That's the most frequent. The biggest percentage. Yeah, you might say it's a tie between 3 and 4 because they're very close, and I wouldn't argue that. List of both. But 28 is the biggest percentage, which means 3 is the mode. Is that fair? Hopefully. Yeah, that's the nice thing about having it grouped like this. You just look. Happens the most. Boom. 3. Let's skip. We're going to come back to the median in a second here. Let's skip to the other data set and do the mode for that one as well. Since now we understand how to find the mode off of this thing. Let's jump to the other tab. It's a lot of work. Jumping to the tab? My God. All right. I'm going to do the sum product again. Make sure we get the averages right. Equals sum product. Okay, I'm going to do this. This was a lot more possibilities. I had to go out to 70, even though I don't think it went to 70. All right, here we go. There we go. All right. I get 14.43 for the average on the back side. Everybody got? Okay, good. I haven't done it yet myself. I threw the data in and haven't looked at it since I threw it in last week. So, okay. Now, what's the mode here? And I think I listed on the homework there might be more than one.
10, 11, 12, 13.
That's freakish. She said with the same instructions. And the very same song. Why are there 4, y'all? Wake your ass up. Why are there 4?
That's the highest point.
Yeah, there's 4 of them that are tied for the most frequent. 8% in each. Highest part of the graph, too. You can actually see them on the graph, which is kind of cool, yeah? You've got 4 of them. 10, 11, 12, and 13. Love it. Love it. So that's mode. Just take a look at the graph or the table and look for the biggest percentages. Because Josie, as Josie said, you said it perfectly. The most frequently occurring data point. That's it. Most frequently occurring data point. Well, I'm just quoting you back, my friend. Cool? Okay. Now the median. This is the one I figured you'd have questions on. Because we hadn't actually done this kind of a median before. We used the command to cheat. Here's a bunch of data. Here's a bunch of data, equals median, bunch of data. So we did that. Let's go back to the first sheet. Okay. Tell me what a median is. Tell me what a median is. What is the median? When you hear that phrase statistically, it can be the average, but it's always something else. What is the average? Let's go back to the average. What's the average? What is an average? When you talk about averages in math, what does your brain think? Do what and then do what? Add them up and divide. Absolutely. Sometimes you'll get the median when you get the average. Like for example, Malia, bell curves. I'm always thinking of doing bell curves now. In a bell curve, the median and the average are the same because the bell curve is perfectly symmetric on both sides. what is the median always? What is the median always? You say that again, Alyssa.
Midpoint between the lower half and the.
Once you put the data in order, smallest to biggest, you then walk to the middle of that line and you find the point in the center. That is the median. So if you think about all this data, it's 100% of the data, right? Where's the median going to be? As far as percentage goes, where's the median going to be? If this is 100%, and it's already in order, right? It's already in order 2 through 7. It's already in order. It's going to be at the 50% mark. Now, it's tempting to say, oh, data's in order. 2, 3, 4, 5, 6, 7. Oh, I forgot a marker. Hang on. Remember every other pile on my desk except my markers. Such an ADD moment. I put the markers 5 feet away where they usually are, and they're basically non-existent. Okay, critique me. Critique me. 2, 3, 4, 5, 6, 7. They're in order already. Well, they are, right? 2 to 7. They're in order. What's that? They're in increasing order. This is when you do a median, you get to put them in order first. So the median is going to be halfway in the middle, right there. Critique that. What's wrong with calling the median 4.5? Malia. There you go. It's not in the middle of the actual bell curve. You see, the problem is, if we put the median right there between 4 and 5, like I just did, we're pretending that the 2 and the 7 and the 3 and the 6 and the 4 and the 5 are like a bell curve. So in other words, we're assuming it looks something like that or something like this. We're assuming that there's the same amount of weight on the left of that arrow as the right of the arrow. Is there? No, there's more weight on that side, so the median is going to be further to that way. Now the question is, where is it precisely? And here's where I kind of figured you'd have questions. The key is the number 50%. That's what Alyssa brought up, that's what Mel brought up. The key is the number 50%. We have to figure out at what point we pass through 50% of the data. So let's just think about it from the table point of view. When we're at 2, how much total percent of the data have we accounted for at 2? 17%. Love that. How about 3? 3 accounts for 28%. So how much total of the data is here? That's 45%, isn't it? That's 45%. Okay. How much data is here? 27%. If we add 45 plus that 27, we passed through 50%, didn't we? We passed through 50%. That means the median, whoa, there go glasses. That means the median is in this bar somewhere. Which means the median is which number? 4. All those numbers are 4. The median is 4. Which makes sense. It should be to the left of that wrong 4.5.
You had to put 3.
Didn't we add these up and get 45? Right. And then we added 27 and we went, but that's not a 50 yet, right? That's not a 50 yet. Oh, maybe I said the wrong thing in June, I apologize. 4 is where we passed through 50%.
Well, because you just said that it was too much.
Oh, no. It's too much, but this is too little. 50% is going to happen somewhere in this bar. Sorry about that. No, I apologize for getting that moved up. So Josie just asked the question, is there a formula not worth learning? It really isn't. Honest to God, it's not worth learning. It's not. I've seen it. I've tried to teach it 25 years ago in stats classes. It just confuses students. It's easier just to look for the 50%. Where does the 50% first happen? I don't know why we caught 3.
So we expect it to be accurate.
No, because you can't. That's the problem. You can't get any more accurate than that without the formula that can. I'd rather you get not super precise and understand rather than trying to use a formula that gets you uber precision. Here's what the formula does. Since 45 gets you to here, we're almost to 50 in here. It wouldn't call it 4, it would call it somewhere between the 4 and the 5. It's not worth the formula. Just logically, where does 50% happen? So it happens in 4, which makes sense to us because it's a little bit left of that artificial middle. Let's apply that to the other one. This, I don't know. I don't understand. No, I could have said it differently. I apologize. No.
You know what? No. I'm so done. I'm leaving.
All right, now here's the other one. This is a much crazier distribution. Much crazier distribution. Smallest number I see is 6. Highest number I see is 70. So therefore, the median is going to be somewhere right in the middle of those two, right about here. Critique that. Malia's laughing at you. That's a good critique. Why is that not the median? Well, first of all, there's nothing there. That doesn't make any sense. That's like yesterday I was doing averages with Math 98. I love it. The very first thing with Math 98. And they were coming up with averages that were impossible. Like the largest data point they could possibly have was 6, and they were telling me the average was 20. And it's good. Like the median can't be here because there's no data here. Okay, all right, let's ignore all this. Biggest data point's 30. Smallest is 6. So the median is going to be about halfway between the biggest one, 2C, and the smallest one, 2C. What do you think about that? Ignore all this over here.
No,
You don't like that either?
I don't like it. Well, I mean, by the little bit on the other one.
Uh-huh.
It would exist, you know.
We don't like this either, do we? We don't like this either because the peak is that way. There's too much weight to the left of that arrow than to the right of that arrow. Now, we can do it the exact same way we did the last time by writing the percentages on top of the bars. But we can also use an old Sheets command that you might have forgotten from Math 98. And we may have done it in here. I don't know if we did it in here or not. If you highlight multiple cells, Sheets will add them at the, let me show you. Sheets will add them at the bottom. Glasses. I do. It's pretty insane. Okay, so only 2% of the data was 6. 4 more percent was 7. Did you see as soon as I highlighted 2 cells down here, the sum went to 6%? Because it's adding the percentages as we go down. We first saw this in the Turtle lab in 98. We used it again in the unit fractions lab. We used it a number of times in 90. I don't know. I'm not sure if we've done it in here yet. Sometimes I forget that some of you haven't taken 98, and I apologize. I forget that. And some of you that did take 98 may have forgotten this little cool spreadsheet thing. Let's keep going until we hit what percentage, as Alyssa said? 50%. Let's keep going. All right. 6. Are we there yet? We there yet? Tell me when to stop. Stop right, Goon. Stop. We passed through 50% where? What data point do we pass 50% at? 13. That means our median is going to be more like over here. There's your median. Half the data is left of it, half the data is right of it. Check out the difference in the shape, though. That's half the data right there, which is very tall and very narrow. This is the data on the others. That's 50% as well. Very different shapes. That's more like that dinosaur we talked about before. So that's why it's hard to kind of figure where the medians are. The average is 14.43. It's over here. It's to the right of the median. And the modes were all over the place. They were over here. So they're all different. And I think that last question I asked on the homework was, why on the first distribution were the mean, median, and mode all kind of close to each other? And here, they're all kind of spread out. What's the main difference in the data set? Scott, what you got?
The amount of data points you have.
You know what? I don't even know how many data points I have. Because here's the problem. That's a great point, what Scott just said. The amount of data points. Oh, I think I know what you mean, actually. You mean the amount of data points down here, not the amount of times I ran the experiment. Because I don't even know what that was. I ran it in class until the graph sat still, and then I copied and pasted the data, so I don't know. So that's a good answer. I like that. We've got way more possibilities here than we did on the other side. I like that answer. Any other answers? I'm going to flip flop back and forth between this one and the other one. Take a look at the graph. Take a look at the graph. There's the second experiment. There's the first one. What does the second one have way more of than the first one? Say that again, Josie. This one has a tail with a lot more data points in it, as Scotty said. The other one's got a little tail too, doesn't it? At 7, a little tiny tail. But it's not as run out as experiment number 2. This one goes up, drops pretty quickly. Malia almost like, it's not perfect, but it's more like a what than the other one? It's more like a bell curve than the other one. And we mentioned before, Josie, when I asked what an average is versus a median, you said yourself, and I loved it. You said median's an average. Can be. For example, in here, median was 4, average is about 4. Mode is almost 4. It's only off by a percentage. They're all about the same. That's because this thing is pretty bell curve. It's got a little tail on this side, doesn't have on this side. But there are no perfect bell curves in the world. They don't exist. If you get a perfect bell curve in the world, something's wrong. This is way more symmetric, though, than this one. And that's what I was hitting at with that last question. This one has a longer tail to one side. The average tends to chase those extreme values. Again, I know I mentioned this in class a week and a half, 2 weeks ago maybe. When you're talking about certain data points, averages are not used. For example, home prices. They don't use average home prices. They use median home prices. Why don't they use average home prices? Remember what we talked about? This has been a week and a half, maybe 2 weeks. Average home price. Let's just suppose, for example, this was actually a graph of home prices in a region. And then somebody sold a house that was way the hell out here. Just one house. Just one house. $12 million house. We're talking about Teton County now. Of course, they would all be over here, wouldn't they? So let's say one house comes way out here. Just one. There's 1,000 houses in this. One house way the hell out here. Mean, median, and mode. Which one just changed? Malia, go ahead. Only the average. The median's not going to change with one weird outlying point here. Because if you have 1,000 points here, 1 point's not going to move that at all. Mode's also not going to change because the high points are still the high points. But the average has to change because of 2 reasons. First of all, the way it's calculated. You add everything up and divide by how many there are, you just added a lot more into that sum, number 1. And number 2, and I know I mentioned this kind of in passing last week, and I apologize, it was just a week and a half ago. The average is really where you have to put your finger to balance a tray of cookies that were stacked. So, right here, we calculated the average to be about 14 and a half, it's going to be right about there. If I suddenly add a cookie way over here, is my hand not going to have to move a little bit to balance that extra? Exactly. So sometimes averages do equal medians, Josie, but sometimes they don't. And it really has, and I don't want to say any more than that right now, but that's 243. Anything more than that is 243. Analyzing it, analyzing how much skew there is, analyzing how much the average changes from the median. That's 243. I want to get you thinking about it in here. Questions, comments? Give it to me. Energy low today. I know. Cool, cool, cool. I predicted questions on at least the medians. Hopefully the modes made sense too, though. Hopefully the modes made sense too. Yeah, Kelly.
I totally missed all of that.
Yes, welcome. Good morning.
Real quick. What were the answers? Just make sure.
It's not exactly how it works, my brother. We'll talk after class.
Fair enough.
Okay, now it's going to be a little bit disjointed today because of I wanted to give these to you last week, but the printer crapped the bed and I couldn't. I emailed this to you Friday or Thursday. I forget when I sent that email. This is the take-home part of exam number 2. I'm going to give you a hard copy now. Then we're going to figure out when that exam is. Because I haven't looked it up yet. Did we look it up?
Yeah.
Oh, we did. I forgot. So I did it 98 yesterday, and I forgot what we looked up. The 12th. Is that a Thursday? I'm going to look it up again. I am on double check.
It's the 10th.
This is why we look
No,
things up.
it's December 10th. It's a
That's
Tuesday.
okay. I'm gonna look it up online, so in case you need to find your other classes, you can find those too. Tuesday. Okay, Tuesday would be the 10th for sure. So I want you to put the due date on this puppy dog. And it's gonna be the same as your exam 1. Take home part, not due till whatever that date is. We're gonna look up and double check and triple check. And then we come in and do the partner and in-class individual parts. But let's check the dates first. All right. All right, let's look up academics. So, in case you need to find, hopefully everybody's talking about, final exams are a big deal at COCC for some reason. I'm not exactly sure why exams are as big a deal as they are, but they are. So, if you ever need to find your other classes' finals from the web page, and I don't know any better way to find it than this, if you could probably just Google exam schedule. I just go to academics and then find the calendar, and it's in there. And usually over here, exam schedule. What if we, you know what? Let's try something. Let's just try Google it. Exam schedule. Oh yeah, that's fine too. Okay, it is a PDF. You have to open it. All right, let's look at this thing. It's opening over here. Let me pull it over. All right, here we go. Okay, fall 2024. I don't want to take it forward. I just want to look at the document. That's all I want to do. There we go. I will opine a little bit as an old man. I miss the golden days of the internet when they weren't constantly trying to sell you something every time you open something. I do miss those days. Just sharing information. When I started teaching math and using the internet, just putting stuff up on the internet, people finding it all over the world, occasionally sending you an email saying, hey, this is cool, you want to collaborate with something? Now it's all spam filters and friggin', yeah, anyway. Sorry, fall 2024, we meet on Tuesday, Thursday, so we're going to skip all these Monday, Wednesdays. Here we go, Tuesday, Thursday. We start at 8 a.m., so it's between 7 and 8:05. Yep, there we go, it's a Tuesday. I wish they put the 10th there, but it's okay. This thing's due the 10th, December 10th. Have it done when you walk in. Have it done when you walk in. And then from 8 to 10 that day, we'll do the partner part, if you want to partner up, and then the in-class individual part. 50 points here. I know it looks like a monster. I mentioned this in the email. It looks like a monster. I was actually just told after I finished it and sent it to you all that by the end of 2026, it will no longer be acceptable accessibility-wise due to our e-learning department. So I think that was the beginning of the end of my teaching career, hearing that what I create has to go through a filter now to make sure that it passes the checkbox muster. So anyway, enjoy it while we can enjoy it. Ask me questions on it, of course. Ask me questions on it if you get stuck with anything. There's a lot of images. That's one of the reasons this monster is as long as it is. Lots of images. There's only a few questions interspersed in between, but there's a ton of images that are kind of explaining as you go. There's some technology you have to, like I'm looking at mine, just looking at page 3 there. Page 3 literally has no questions on it for you to do, but it's got a humongous image bank that explains what you're going to be doing. So that's why this thing is as massive as it is. And I thought about not including the images, but I'm like, you know what? I think it's going to help because I have you using an outside web page to get numbers. And I figured you might freak out a little bit if you went to that web page, which is linked in Canvas. Oh, let me show you in Canvas too. You got some links in there, a couple videos. And hang on. There we go. Let's go back to the modules. I stuck them in week 12. Week 12. I keep forgetting. There we go. So you got tons of links. This right here takes you to that web page that you're looking at those images on the first few pages. These are optional. I put those as optional. The second, it's really 2 questions. Typical starting exam. 2 questions. 2 questions. Of course it is. 2 questions. Of course, those questions have like 6 subparts each because that's what Sean does. The first question is similar to the homework we just went over. You're looking at an experiment, but it's not flipping coins. It's not drawing cards. It's not rolling dice. It's going to Target and buying little Lego minifigures. Yes, we want to make sure we get them all. How many do we have to buy to make sure we get? And the answer is it depends. It really depends on how random they are shuffled, which is the whole point of the question, is analyzing that. You're gonna see a lot of similarity between what we just did in that homework and that first exam question. The second one is about the randomness of my buddy Jenny's calling random numbers in a cross-training class I have. So these videos show me suffering while Jenny's calling push-up numbers. You don't have to watch it. I mentioned them in that thing. You don't have to watch it. If you want to see me suffer, by all means, watch it. They're about a minute and a half each. And then this last video down here is right before the last question on that take-home part. Take your time. You got plenty of time to work through this thing. It's not going to take you 3.5 weeks to do it. But I know how busy you all are, so it might take you 3.5 weeks to find time, 10 minutes here, 15 minutes here, 20 minutes here, to knock through it. Work with each other. Ask me. Whatever you need. Whatever you need. Cool, cool? Questions you got right now? Any questions you got? I know, Josie, I know. I just handed you 5 pounds of paper. There you are. I know. Legos are a huge part of my family's life. I've been playing with since I was like 8 years old, and our family has tens of thousands of them in our attic.
Nothing worse than sitting on a Lego barefoot though.
You know what's funny? I never thought about that until 5 years ago, when all of a sudden every other video on my Instagram feed is people complaining about that. I'm sure it does. I've never done it. It's crazy the amount of time.
You're lucky if Lego's part of your life. I don't know.
I know.
I tickled your foot and you didn't feel it. You probably have.
Oh, maybe I had. That's true.
I have
I got climbers feet. They're basically footballs on the bottom of my stumps. Big leathery soles. Okay, does that make sense? When's that due? December 10th. You have plenty of time. Plenty of time between now and then to whittle away at it. And there's nothing on it you haven't done yet. Everything on that take-home I just gave you is stuff we've already finished in class. That's another reason why I wanted to give it to you now. Because that way you don't have to. We're going to do more. Today, we actually start the back third of the course, which is financial literacy. I know. It's a weird year shift. 105 is strange. Like I said, when the state redid it years ago, they dropped this financial part into it. Intentionally, or their intentions were very, very good. Many students come through an entire high school career, and even college career, without ever looking at money math. Think about that. Well, in large part, there's a lot of theories we can have about why, but this is one of the things is just understanding money, saving money, borrowing money, paying down money, the time value of money through time. So the state, I love that they intentionally did this. We're going to put this in Math 105. That's awesome. I asked the state 10 years ago, you should have an entire course on this, not just part of one course. And they said, nope, they also have to know probs and stats and financial math. All right, put the course into 3 pieces and we'll do probs, stats, and financial math. So welcome to the back third. Here we go, financial
I have a
math.
question for you.
Ask me, please. While you're asking me, I'm going to hand out warm-up. Is that okay?
Yeah.
Go.
I recall you saying in '98 that in this class you need to watch me build the site.
Well, we were going to do that. The problem is, between then and now, I realized that doesn't actually fit any of the 105 outcomes. Well, I may have a video I can show you. People have recorded it over the time. Hilariously, years ago, I remember this vividly. I did record one of the days I did it about 5 years back. Posted it on YouTube because somebody else needed to. No, I never posted it on YouTube because I lost my camera after that day. And 4 years later, I got a call from public safety. Hey, I think we have your video camera down here. Somebody had picked it up. It sat in Lost and Found for 4 years. Nobody thought to turn the camera on and look at what was on it. To see like, hey, maybe there's some identifying
Mark.
like here's a dude riding his bike down the hill, yelling at his class. I wonder who that is. It was actually one of my former students who started working for public safety that found it, which is hilarious.
Oh,
So anyway, it's not the camera I'm using right now, it's the other one.
Can we get one more?
Of course. Yes. Yes. Now, this one here, this warm-up, we're going to look over the next, I got 5 more days in here. We're going to make them count. We're first going to look at inflation, which has been in the news for like the past, God, 10 years, every party complains that the other party is not doing anything with respect to inflation. And I don't want to get into the politics of inflation. Because personally, I don't think there is any politics of inflation. I think politicians blaming the other party for inflation is missing the larger point. Neither party controls inflation. Capitalism is a large part of what controls inflation. But the first thing I want to do first is do some Googling and tell me what is economic inflation. While you're Googling that and looking that up, I'm going to hand some papers back. All right. Alyssa. Here you go. Oh, when we get a second, I'm going to tell you a story about this. I saw your awesome note last week, and I never got a chance to follow up with you. If we have time. But I did not know that factoid you dropped on me, so I appreciate that. Love learning new things. Bell curve, Josie. You got it.
Your Tesla shutter not working?
Does it not work? I don't know. I never use it. Is it plugged in?
I don't know.
I never use that damn thing. I'm sorry. Metal.
Looks like it's plugged in, but it's not working.
If not, I know. I think the. Oh, you got it. You got it. You got it. There you go. Yes. Good. Yes. Oh, look. That's our homework. Or our homework. It's backwards. Well, not really. I guess it keeps going up, which would be inflation. But then you got this one. Up the damn hill. Up the damn hill, woman. Forever linked to bell curves. Oh, that's okay. That's okay. Sorry about all the notes. You had things in different places on it. No, you're good. You're good. Everything was good. I just couldn't find it at first, but then I did, so I apologize. And I used a damn Sharpie, which means I can't fix it when I'm done. Jeez.
No way. Something costs it.
James.
Thank you.
You got it. Oh, poor James.
Poor James.
Failed on me. There you go, my friend. Natalie. Esther. Shannon. Your email come back. We'll get it all figured out. Oh, that one. I got you. I did screw up. Your emails got in. I get my email back where I said I totally bombed it. I put it in. You'll see it this week. So that's taken care of here. That was just so many emails came in that week, and I saw it come in. I'm like, no problem, I'll take care of it. And then what I should have done was right then put it in, and I didn't. And then I sat there. Don't worry about it. You'll see it. You'll see it this week. I got you. Okay, you badasses. Insufferably badass. That is. What's economic inflation? Say that again, Natalie. That was pretty quiet for you. Whoops.
It is the rate of increase of prices over a given period of time.
Ooh, the rate of increase of prices over a given period of time. I like that. Who else found that same definition? I got a feeling many of us found the same thing. Good. Anybody find anything different? Rate of increase. I'm going to write a couple of these words. I'm not going to write the entire thing, Natalie, but I like the word rate. Rate of increase. I like that. Anybody else?